Section 7.1, the law of sines. We're going to use the law of sines to find unknown parts of a triangle. Sometimes triangles are not right triangles, so we can't use the right triangle trig with them. So what we can do is, for ones that are not right triangles, we can use trig to determine the law of sines and then use the law of sines on those triangles. So I am going to define or prove the law of sines to you. I have a triangle there, and I drew a height for that triangle, and I just called that h. So I dropped down my perpendicular from that top angle, angle B, and I called it h, my height. And now I have two right triangles, one on the right side, one on the left, that I can do some right triangle trig. So when you look at the triangles, let's look at the left triangle. I could do the sine of A is opposite over hypotenuse. My opposite side is h and my hypotenuse is c. So for the triangle on the left, sine of A is equal to h over c. And then I solve that for h. So c sine of A is equal to h. Now the triangle on the right, I could do sine of c is equal to my opposite over hypotenuse, or c is equal to sine of c is equal to h over a, and solve that for h also. Same h, same height. So I can set h equal to h. So h is equal to h, or instead of h, I can call it c sine of a, and for the other h, instead of calling it h, I can call it a sine of c. So c sine of a is equal to a sine of c. Do a little bit of algebra, divide each side by a, divide each side by c, cancel where you can, and then you have sine of a over a, side a, is equal to sine of angle c over side c. And that's just proving two of them. But the law of sines is written as the sine of a over side a is equal to sine of angle b over side b is equal to sine of angle c over side c. So on this, we have to know three parts of a triangle. We can know any two angles and a side. Or we can know two of the sides and one of the angles opposite that's not included. Okay? And we can use the law of sines. If it's not, if we know two sides and an angle, but the angle is not one of the ones opposite, then it's not, we could use a different law of cosines, and we'll talk about that in the next section. So here, I have a triangle. Triangles ABC with sides, lowercase a, b, and c. I'm giving you that angle A is 50 degrees and angle B is 65, and side A is 12. So solve the triangle. The first thing we can find easily is our missing angle. We know the sum of the three angles is 180. So 180 is equal to 50 plus 65 plus angle C. So angle C is 180 minus 50 minus 65. And so there is my formula. And I get 65 degrees. So that's the first thing I can find very easily. So now, looking at the triangle, I have all three angles. And two of the angles are equal. So it's an isosceles triangle. So if two of the sides or angles are equal, that means two of the sides are equal. So if angle B and angle C are equal, that means side B and side C are also equal. So now on this one, I only really need to find one side because the other one will be the same. So then use law of sines. So I have the sine of my angle. A is 50. So the sine of 50 over A is 12 is equal to the sine of, and you can do any angle, it does not matter, but sine of 65, and it really doesn't matter if B or C is 65, they're both what I'm doing. so I've called it angle B, sine of 65 over B. Cross multiply and solve for B. So then you'll get B is equal to 12 sine of 65 over sine of 50. Cross multiply. And then pick up your calculator, put it in your calculator, make sure your calculator is in degree mode, and you'll get 14.2. So side B is 14.2. And remember, if angle B and angle C are equal, side B and side C are also equal. So C is also 14.2. If they weren't equal, you just use law of sines again, which would be sine of the angle C over side C. Next one. I have two angles given. Angle B is 30 degrees. Angle C is 70 degrees. And side B is 10 units. Easily I can find my missing angle. So why don't you find your missing angle? Well, that will do easily. 180 minus 100, 70 plus 30 is 100, gives you 80. So 80 degrees is my missing angle. Okay? Now to find A, you could use sine of 80 over A is equal to sine of 30 over 10. Plug it in your calculator and see if you get 19.7. And to find C, use law of sines again, see if you get 18.8. If you are using a calculation along the way in your calculator, use the storage feature. Store your numbers if you're going to use them. I always try to use exact numbers. So if I was going to do this, I would use sine of 30 over 10 with sine of 80 over A, and then I do sine of 30 over 10 is sine of 70 over C. Okay? But pause it, try it, make sure you get the right answers, and then restart it to make sure you did it correctly. There's your one answer. And there's your other. So hopefully you have it right. And make sure it makes sense. Largest angle across from largest side. Smallest angle are across. Middle size angle and middle side is also opposite. Another example. Here I have one where I have two sides and one angle given. Unlike the last one where I had two angles and a side given. So here I can do sine of 40 over side B, which is 20, is equal to sine of A over 18. Multiply each side by 18, and you have 18 sine of 40 over 20 is equal to sine A. To find angle A, I need to take the inverse sine of this. So put the inverse sine in your calculator, and then you'll get angle A is 35.3. So angle A is 35.3. Remember, the sum of the three angles is equal to 180. So then do your math and then use the law of sines. I'm not going to finish this problem. I just wanted to make sure you realize if you had to find an angle, you used inverse. Okay? If you have two sides given, a side and an angle, and that angle is not an included angle, so I have a side A, a side B, and an angle, and I'm calling this angle A. You can either have, I will give you numbers for that, and you'll either have one solution, two solutions, or no solutions. Okay? And let's say this came down straight this way. You'd have a right triangle. So if this were side A, you would know that the sine of A is equal to the opposite over the hypotenuse, or A over B. So you would know that the sine of A is opposite over hypotenuse. Multiply each side by B. And if B sine of A were exactly A, you would have a right triangle. And that's this one right here. But if this side right here, A, was too short, so it's not long enough to meet that side, it's too short. So if A is less than B sine of A, there won't be any solution, because this is fixed size, that's a fixed length, this is a fixed size, it's not long enough to meet the other. So that would be no solution. If your A was greater than this B sine of A, but less than this length right here, this side A could swing in, like this, or it could swing out. This line is not given. You don't know how long that is. Okay? So it could swing in, and if it swung in, your triangle would look like that. Or it could swing out, and your triangle would look like this. So that would be two solutions. If this side A is longer than B, if it's longer than B, it can't slide in because it wouldn't hit that. It would be too long. It can only go out, and there's one solution, one triangle. So you can either have no triangles, no triangles, one triangle that's a right triangle, one triangle that's this obtuse triangle, or you can have two triangles. Okay? So these are the four cases I've written here. So let's figure out how many solutions that each has. So I drew the triangle, and I always put my angle that I know here, whether it's A, B, or C, and then my opposite side, B, right there. Okay? So angle B is 30, side B is 4, and then this side is my other side, A is 8. Okay? So if it were a right triangle, you would know that the sine of 30 is equal to opposite over hypotenuse, 1/2. And sine of 30 does equal 1/2, so this is a right triangle, and it's one triangle, and it's a right triangle. Okay? Now, I have a side A given as 45, the opposite is 4, and this side adjacent to my angle is 6. Okay? So now, remember, the sine of 45, does that equal my opposite side over my, if it were a right triangle, that would be my hypotenuse. The 6 sine of 40, does that equal 4 to give me a right triangle? And when you calculate it, 6 sine of 40 does not equal 4, it equals 4.2. Okay? So what they're saying is, this has to be 4.2 in length, this has to be 4.2 in length to meet this other side. It's not. It's only 4. So it's too short. So no triangle is formed. For C, if you figure out what 7 sine of 60 is, you'll get 6.6. So the minimum distance to make a right triangle would be, or 6.06. So the minimum this has to be to make a right triangle is 6.06. It's longer than that, it's 6.5, so we'll make a triangle. And since it's less than the 7, it can swing in and make a triangle, or swing out and make a triangle. So it makes two triangles. And then the last one, you can just look here. You don't even have to do the calculation. You can if you want. you could do 5 sine of 70, and you'll see this minimum distance to make a right triangle. But all you really have to do is look at this. This angle, or this side, is 10. It's larger than that side, which is 5. So you can only do one triangle that swings out. So solve each side angle triangle. Indicate whether the given measurement results in no triangle, one triangle, or two triangles. Solve each resulting triangle. Round your answer to the nearest tenth. So if I were doing this, I would say, I like to draw them out. So if I was drawing it, this would be my angle A is 36. My side A here, I don't know where it goes, but side A is 30. And B is 24. Okay? So if I pick up my calculator, and I don't have my calculator on yet, but I will go get it. And on my calculator, if I put 24 sine of 36 in the calculator, so my calculator has to be in degree mode. And so if I do 24 sine of 36, that opposite has to be at least 14. But I didn't really need to do all this. It has to be 14 to make a triangle. I really didn't need to do that. All you really needed to do was look here, that 30 is greater than 24, so you can only make one triangle that goes out. Okay, so it is one triangle. So then now use law of sines. I probably have that written somewhere. Law of sines. Sine of A, which is 36, over 30 is equal to sine of B over 24. Solve for B. So first I solve for sine of B, and now I have to do inverse sine to find angle B. And if you put it in your calculator, you should get about 28.0. Okay? And when you do this, go back to the unit circle. This is 28.0. Remember though, inverse sine only gave you the acute angle, the one in the first quadrant. It doesn't give you the obtuse angle, which is the one in the second, the second quadrant, because sine is positive in the first quadrant and the second quadrant. So this angle right here is 180 minus the 28. So it's one of those two angles, okay? It's either 152 or 28. But when you're looking at it, if this angle is 36, it can't be 152 because 152 plus 36 is greater than 180, and all three angles have to be between, or all three angles have to add up to 180, and two of them are more than 180, so only one angle. So it's 28. And so now to find your second angle, you have one that's 36, one that's 28. If you take 180 minus the sum of 36 and 28, you will get your angle C. So now I have my angles, and the only thing I'm missing is side C. I do not have side C. So you can use trig. And notice, I told you before that the law of sines was sine of A over A is equal to sine of C over C. This is also the same thing. I just rearranged the formula. So you could write it that way if you want. So A is 30. Angle A is 36. Side C, I don't know. And angle C is 116. So put it in your calculator. And you should get 45.9. So let me do it in my calculator and let's see. Here's my calculator right here. Okay. So I have this right here, and I'm going to put stuff in my calculator. Let me go back to this right here so you can see where all the numbers are coming from. I'll do it over here so you can see what I'm doing over here. When I found this right here, angle B, I did inverse sine. So I did second first to do inverse sine. And since I have a fraction there, I'm going to pick up my fraction key. And in the numerator, I have 24 sine of 36. And in the denominator, I have 30. So there's angle B. And here's what I mean by using exact values and storing it. I can store this anywhere in my calculator I want. So I am going to store STO, and since that's angle B, I'm going to store it in B. So I just put that in B. Okay, so let me just show you. I'm going to pull up B. There it is. Okay? So if I want to do angle C, remember angle C was 180 minus, whoops, not a second, B minus 36. So there's angle C. And I'm going to store that too. I'm going to store that in C. So now they're stored so I can use them later on. And so I'm going to use it right here now. My fraction, 30, sine, that's angle C, so of C, over sine of 36. And you get 45.9. And that's what I had there. So you see how to put it in your calculator. Solve this triangle. When you're solving this one, you can also do it a little bit algebraically too. If you don't use the logic we use, if you use your law of sines, and here's my law of sines, and then solve for sine of B, and then later on solve for B. So there's sine of B. Okay? You can pick up your calculator and just let me show you what you get in your calculator so you can be able to read this. If I were solving this right here, you would do B is equal to inverse sine. So let me show you on your calculator what happens. Inverse sine of, I like my fractions, so I'm going to do the fraction. 40 sine of 62 is my numerator, and my denominator is 30. When I put that in my calculator, you get error domain. If you get that in your calculator, it means no solution. And the reason is because this 40 sine of 62 over 30 has to be between -1 and +1, and it's not. So you get an error. So it's no solution. And on this test, you will be using your calculators. So on this test, you will use a calculator because I'm not going to give you the exact answers. I'm not going to give you all like sine of 45 and sine of 30. Some of them might be, and those I might say find the exact answer. If I write find the exact answer, you know that it's a special triangle. And then here's another one. Solve this triangle. Indicate whether the given measurement results in no triangle, one triangle, or two triangles. Solve each resulting triangle. If you want to check the triangles like we did, using the rules from here, right here, you'll see that this side times the sine of the angle is less than this opposite side. But this opposite side also is smaller than this one for that one. So on that one, if you do that, you will make two triangles. So this will have two solutions when you do it. And like I said, if you want, you could draw your triangle and say, okay, when I'm drawing it, I have an angle here, 32 degrees is my B. Here's the side B, which is 50. And here's the side C, which is 60. Okay? So if you do 60 sine of 32, you'll get something less than 50 to make a right triangle. Since it's more than 50, it could swing out and make a triangle, or swing in and make a triangle, because it's less than that 60. Okay? So I know it'll make 2 triangles. So now, use law of sines. So sine of 32, which is my angle B, over side B, which is 50, is equal to sine of C over 60. Multiply by 60, and then take the inverse sine. Okay? So you have your calculator, and on your calculator, you will do inverse sine. I'm going to pick the fraction again. Numerator, 60, sine of 32. Denominator, 50. And I have 39.486. That's my angle C. So I am going to store in C. So now it's in C. So whatever I had in C before, I overwrote it. That's what's in there now. Okay? And let me show you that it's in there. Okay? So that's in C. Oops. So let me get rid of that. Okay, so that's what you got in your calculator. But then you have to remember that sine is positive in both the quadrants. So it can be the 39.5 that I just had in my calculator. Whoops, did I get rid of it? I need to pull up my calculator again. Didn't mean to X out. So it can be that 39.5 that I had in my calculator. Or I could be in the second quadrant, which is 180 minus the 39.5. Which is 40.5. So one angle is 32. C can be 39.5. Some of those is less than 180, so yes, I could have another angle there, triangle with that one. Some of these two, it's also less than 180, so I could get, those could be 2 angles, and then I could have a third angle. Okay? Okay, so if I'm doing that, angle B could be 32, angle C could be 39.5, and angle A could be 180 minus the sum of those, or angle A could be 180 minus the sum of these. So 180 minus the sum of the 2 smaller angles, or 180 minus the 32 and the 140.5. Okay? So that's what I have right here. So I have, let's see, angle C. If angle C is 39.5, angle A would be 108.5. If angle C is 140.5, angle A is 7.5. Okay? And then using law of sines, you could figure out if the angle is 108 that I'm going with, the angle A, and angle C is, whatever it is, 39.5, use the law of sines to find side A. Given side C, put it in your calculator. If angle A is a 7.5, then I have side B over the sine of angle B is equal to A over the sine of angle A. When I plug the numbers in, you'll have 50 sine of 7.5 over sine of 32. And that'll give you A. Okay? And when you put it in your calculator, you should get 89.5 and 12.3. Okay? So those are the other angles or sides you should get. And like I said, when you're doing these calculations, store them in your calculator. So I already put angle C in the calculator. I could do angle A in the calculator also. 180. Move it over a little bit. Minus 32. Minus C. Alpha C. There's my 108.5. So if I do sine of 108.5 times 50, so if I do sine of 108.5 and my parenthesis times 50 divided by sine of 52 divided by sine of, so I said 52, 32. There it is, 89.5. Okay, so I just did one of them here in the calculator.